Okay, so now let's look at some cases of accumulation area, ablation area in the wild, and what kind of features can indicate on a glacier can indicate that you're in the accumulation area or the ablation area. This picture is pretty nice. We more or less put the ELA here at the transition between outcropping ice and snow on top of the glacier. So you can see the accumulation area of this glacier is pretty big compared to the ablation area. So this glacier might be advancing. Or it could be the other case where actually this glacier was much, much bigger and the ELA has moved from far down in altitude and it has moved up on the glacier, has been moving up on the glacier and reached that point where most of the ice here doesn't melt away because it looks like it's at pretty high altitude. There are very specific features associated with accumulation area and ablation area. If you look at the altitude of the surface, there's a lab on topographic maps where you try to recognize from topographic maps if you are looking at the accumulation area or the ablation area of a glacier. So how can you recognize that? Well, if you walk across the accumulation area, you might realize that the profile of the ice is a bit convex, meaning it's kind of bulging up. Therefore, if you look at a topographic map, the accumulation area will really have that, I don't know how to say that, the inverse of a U shape, basically. And as you go down on the glacier, those lines representing, so those are the isolines, meaning the lines of same altitude. If you're here, if you want to walk across the glacier and stay at the same altitude, you will have to walk along that line. And if I'm far up in the accumulation area, if I want to stay along the same line of altitude, I actually have to walk a bit up glacier to stay at the same altitude. That is a direct effect of that kind of bulging scenario here. So what you have is accumulation areas have this bulge, and as you go closer to the ELA, those isolines of a glacier will become more and more straight. They will not be deformed in one direction or another. And when you reach the ablation area of the glacier, you enter what we call a concave shape. It looks like a U. So basically, if you're walking on the glacier and you're trying to stay at the same altitude, you have to go down a bit. So the glacier is really displaying that concave shape like that. If you are looking at a topographic map of Alaska and you have a glacier, you might be able to see where the ELA is when you see that transition between like that upside down U shape to that transition to the that U shape here. And when the lines are straight, it means that that's probably around where the ELA is. If you are taking pictures of the ice, you might recognize an ablation area from the appearance of the surface of the glacier. In the ablation area, you will have many more crevasses, moulins, lakes, and stuff like that, meaning the ice is really melting a lot. Accumulation areas have fern, they have snow, and those materials are permeable, meaning that the water goes through that. So if you have melt that's occurring in an accumulation area, you might not see it from like a helicopter or a drone or by walking on it, because it will be kind of like a sponge. The water is there, but you can't really see it. In the ablation area, there's no snow, there's no sponge on the surface. So all that water that you see is either being stored there or it's going through the glacier. And there are multiple features of ablation. So you have crevasses when the ice is strained apart and it's kind of breaking, and will form those lines, features that are a bit deep, but it rarely goes beyond 30 meters of depth. You can have moulins that are what we see here on the pictures. They are usually circular holes or more circular, and they go to the bottom of the ice. That's a good way to transport ice throughout the glacier. So you have your surface here, and the water is basically falling down, goes through the entire ice pack and reaches the bedrock, or the interface between the ice and the rock. That's a moulin. And that's kind of characteristic of an ablation area. Crevasses, as I said, are made when the ice is strained apart, meaning that in areas where the ice is flowing very fast, you will have more crevasses than usual. And the shape of those crevasses and the direction compared to the main flow can tell us where we are on the glacier. If we take that glacier here with the flow going from right to left, we'll have different type of crevasses depending on where we are. When the ice is accelerating, we will have those convex type of crevasses that really go across the glacier. As you enter a more steady ice flow area, you will have crevasses on the sides of the glacier. You have shear at the valley walls, and as you enter a part where the ice is slowing down, you will have different types of crevasses, where, for example, splaying crevasses that are more in the direction of the flow, while crevasses before were kind of perpendicular to it or with an angle of 45 degrees to it. So if I give you a picture of a glacier and you see splaying crevasses, well, if you see crevasses, you should be able to say if you know where the glacier is flowing. If it's a splaying crevasse or a transverse crevasse or longitudinal crevasse. There's an example of that in the lab, I believe, where you have to recognize what kind of crevasse you have on the picture. So, small quiz prep. The ELA of a glacier is the elevation at which the amount of melt exceeds the amount of snowfall. That's wrong. There is no precipitation that falls on the surface. That's also wrong. Where the amount of ablation is less than the amount of new snow. That is also wrong. And the right answer is answer D, where the amount of ablation is equal to the amount of accumulation. Another quiz. This glacier here, that's the Muir Glacier, Glacier Bay National Park, sorry. So the terminus of this glacier will retreat as the Muir Glacier did if the amount of ablation exceeds the amount of accumulation, or the amount of accumulation exceeds the amount of ablation, waves erode the terminus, or the amount of sublimation exceeds the amount of melt. Here, the right answer is answer A. The amount of ablation exceeds the amount of accumulation. It makes sense. You take more material away from your glacier than you put material on the glacier. Output is bigger than input, so the glacier is retreating. Waves eroding the terminus, that's not really a thing. The glacier will calve away and lose mass with that, and can be actually a pretty important process in the retreat of a glacier or how a glacier is losing mass, but the waves don't really erode the terminus. That's the ice that's falling into the ocean more than the other way around. And that's for the next video.